In this question, we're told that Kim and Tom are both learning to tune a violin. Kim's teacher asks her to tune the A string of her violin to the correct frequency in hertz. When Kim tunes the A string, its frequency can be modeled by a normal distribution. When Kim first starts learning, she tunes the A string with a mean frequency of 443 hertz and a standard deviation of 6 hertz. The correct frequency is actually 440 hertz. We're asked to find the probability that Kim tunes the A string lower than the correct frequency. Okay, let's just start off with the distribution. We know that X is going to follow a normal distribution. The mean we're told is 443. Standard deviation is 6. Let's see that on a diagram. And the probability that she tunes it to be less than 440, we can find with our NCD calculation. We're looking for this region, everything below here. So looking for a small probability, smaller than a half. On the calculator, we get 0.3085. For part B of the question, we're asked to find the probability that she tunes it more than 5 hertz away from the correct frequency. Well, the correct is 440, and if she was exactly 5 hertz away, she would be getting it at 435, or she would be getting it at 445. So this black region is the correct region, or it's within 5 hertz, and the blue region is outside or beyond or further than 5 hertz away. We're looking for the probability of the blue region. So an easy way to find that, or a straightforward way to find that, is just to actually find the black region and subtract it from 1. So 1 minus the probability that X is in between 435 and 445. That gives us an answer of 0.4607. Next, we're told that after practicing for some time, Kim tunes the A string with a standard deviation of 4.5 hertz. She's getting better at tuning the string. The standard deviation is reducing. She's becoming more consistent. She claims that the mean frequency when she tunes the string is now less than 443. Kim's teacher asks him to tune the A string 20 times and finds that the mean frequency is 442. So the mean of the sample was 442. We're asked to test at a 5% level of significance whether or not there's evidence to support Kim's claim. Okay, set out the information that we have. She's tuned the string 20 times. That's the sample size. The mean that her tutor collected is 442. That's the sample mean. The original normal distribution, or at least the improved normal distribution, is X follows a normal, where mu is 443, and the standard deviation is 4.5. The X bar distribution, this is the important bit. The X bar distribution has the same mean, but now we have sigma over root n, 4.5 over root 20. This is the X bar distribution. This is the distribution we're going to use to calculate our test statistic. Let's start the hypothesis test. The null hypothesis is that mu equals 443. The alternate hypothesis, mu is going to be less than 443. We're working at a 5% level of significance, and quickly, here's the diagram. So, in our sample, we got 442. We're going to find this area. If this is smaller than 5%, we have a significant result. The probability is less than 442. In our calculators, our minimum, our maximum, sigma over root n for our standard deviation, and our mean. That gets us an answer of 0.1602. So, is this a significant result? Well, no, it's not. It's quite large compared to 5%. So, 0.1602 is larger than 0.05. So we do not have enough evidence to reject H0, and we do not have enough evidence to show that the mean frequency when Kim tunes the string has reduced. Okay, part D of the question. We're told that when Tom tunes the string, its frequency T can be modeled by a distribution T which has an unknown mean and standard deviation. we're given two probabilities. The probability that t is less than 438 equals 0.2, and the probability that t is greater than 445 equals 0.1. So 20% and 10%. Let's see these on a diagram. This is the sort of question where we do not know the parameters, so we're going to want to rely on the standardization formula. Z equals x minus mu over sigma, and we're going to match up a real-world t-value and a z-score. Well, the z-score that has 20% below it is negative 0.8416. That matches with 438, and we can substitute that into the formula and rearrange to get an equation that involves mu and sigma. So, substituting these in, I'm just going to multiply across by sigma. We can do a similar thing for the other probability statement. The z-score this time round is 1.2816. Rearrange, and once again, we've got an equation in terms of mu and sigma. I'm just going to rewrite these in the usual form that we'll see simultaneous equations, move all the unknowns to one side, all the constants to the other side. And you can go ahead and solve these simultaneous equations any way you want. I would strongly recommend, that you just use the equation solver on your calculator. Substitute these values in, and your calculator will show you that sigma equals 3.2978 and mu equals 440.7735. The question asked us to give these values to one decimal place, 3.3 and 440.8.